Hey physics fans, it's Mr. Russo, and for those of you not willing to get out of your seats to be tactile learners, I am doing, and those of you who are home, I'm doing this demonstration on magnetic induction for you. So these are the contents of the kit. I've got 3 different coils. This one has 40 wraps, 130, and a whole lot more. And a magnet and a Gauss meter, which is a really sensitive meter because we can't see electrons, so the meter will tell us whether electrons are moving or not. So I need to connect to it. So let's start with our smallest coil. And there's one of the frustrating things about being a tactile learner is sometimes the equipment fights back. All right, there's one side. There's the other. I really like this demonstration. To me, it's one of the biggest takeaways for the entire unit is this concept. All right, so I now have an electric circuit, right? Any electrons moving have a path to go now, right? From one end of the loop, through the galvanometer, and back. All right, so take a magnet and put it in. Oh, are we watching the meter here? I'm seeing when I put the magnet in or out, swap it end for end, I'm seeing that the needle moves, so that's an indication that electrons are moving. Let's see what happens if I up the number of coils from 40 to 130. All right, so that's like, well, it helps to have connected to the right coil. All right, that's like 4 times as many. Watch that meter. Oh, looks like the meter moves a little more. All right, so the number of coils matters. Let's go big here, right? Might as well. All right, so I've got the biggest coil that I have. Well, not in the kit anyway. All right, so here we go. A larger coil. Oh my, watch that meter. Jumping around. All right. So we've definitely cemented our theory that the number of coils matters, or the wraps of wire, and that's basically a multiplying effect, right? Instead of one wire, this would work with one wire, but you hardly make any electrons move. But if I coil a lot of the same wire around and around, I multiply the effect. So let's just take the north end of the magnet, put it in, I'll move it slowly, I see some movement. If I move it fast, whoa, pegs right out. So how fast I move the oh, look at that. I do it outside, nothing, or very little, right? But if I move inside the coil, much higher. Oh my. All right, so how fast I move the magnet, or the magnetic field, it matters. All right, last piece. Let's do an experiment with which end. So here is the north end of the magnet. You see the end? If I put the north end in, the way I have it hooked up, the needle goes left. When I pull the north end out, the needle goes right. So polarity matters. Let's just double check that. Let's swap that. So now I'm putting the south end. Oh, when I put the south end in, it goes to the right first. When I pull the south end out, it goes left. So the polarity of the magnetic field matters. It makes electrons move one way or the other. The speed and the number of wire wraps. So this is the basics, the very basics of the next 2 phases of, pun intended, of the packet, which talks about motors and generators, right? It's this technology, moving magnetic fields and coils of wire, that is a giant technological breakthrough for humans. And you.